Hey guys, this is Mrs. Rooker, and I'm going to be doing 5.1 with you guys. So if you want to pause the video really quick and work on the review problems 1, 2, and 3, and then I'll have the answers for you when you're done. For the answers, remember for number 1, you need to divide out or factor out that b value, and that's how we get 1/8. The minimum value, that can be found because the midline is going to be shifted down 9. And then the amplitude is 7, which means it's going to go 7 below that midline, taking us all the way down to -16. And then for number 3, remember tangent is the same as sine over cosine, which kind of leads us into the next part where we're going to talk about trig identities. So the goal is to use trig identities in order to simplify expressions and prove identities. So, review. Basic trig ratio identities, just like we had above, tangent of x equals sine x over cosine of x. And then that kind of goes along with cotangent. Remember, cotangent is the reciprocal of tangent. So cotangent of x is going to be cosine of x over sine of x. And then our basic trig reciprocal identities. I'm just going to pause the video and put them all up there. Here are all the reciprocal identities. Hopefully you have these memorized already. Sine of x is the same as 1 over cosecant of x. Cosine of x is the same as 1 over secant of x, and then tangent of x is the same as 1 over cotangent of x. And then obviously the opposite is true for all of those as well. Other big identities that you need to know are the Pythagorean identities. I'm sure you have the basic one memorized already, cosine squared x plus sine squared x equals 1, and then there's a lot of different variations of that. So that's the same as cosine squared x equals 1 minus sine squared x. That can be found by basically just subtracting sine squared x from both sides on this first one. I'm not going to write all of that. It's going to be a lot to write down. But that's how that can be found. Oops, sorry. Keep my arrow there. And then that is also the same as sine squared x is equal to 1 minus cosine squared x, which also can be found from this if I just subtract cosine squared x from both sides. So those are all very closely related. It's another variation on the Pythagorean identity. It's 1 plus tangent squared x equals secant squared x. And then we're going to do a bunch of variations on that as well. So if we want to subtract tangent from both sides, that's going to be the same as 1 equals secant squared x minus tangent squared x. And then that's also going to be the same as tangent, oops, trying to keep it nice and color organized, tangent squared x equals secant squared x minus 1. So those are all related to each other. And then the last variation that I'm going to write down, let's find a different color. Let's do green. Don't use that often. So that's going to be cotangent squared x plus 1 equals cosecant squared x. And then we can get a variation on that. If we want to subtract cotangent squared x from both sides, we'll end up with 1 equals cosecant squared x minus cotangent squared. And then if instead of subtracting the cotangent for both sides, we can subtract the 1 from both sides, and we'll get that cotangent squared equals cosecant squared minus 1. All right, so pause the video if you didn't get that all written down, because those are going to be trig identities that we are going to use a lot this chapter, and it's definitely going to be a good idea for you to memorize these. At the very least, memorize these, and then know how to use those to find the other ones when needed. All right, so we're going to move on to simplifying each of the following expressions using trig identities. So we're going to simplify each of these and try to condense them as much as we possibly can using any of the information that we have above. So I'm looking at this first one, and I'm trying to look at how I can either cancel things out or combine things. And I notice that I have cotangent and tangent, and those are related to each other. I don't like dealing with cotangent that much. I'd prefer to convert that to something else. And I know that cotangent is the same as 1 over tangent of x. So I'm just going to replace that with 1 over tangent x. And then you might notice, well, I guess I don't really need to put that over 1. We now have tangent on top of a fraction, tangent on bottom. Those will cancel out, and we'll be left with just 16. And that's as simplified as we can get it. Moving on to the next one. Again, I don't really love dealing with cosecant. I'd rather convert that to something I know. So using the reciprocal identity, cosecant is the same as 1 over sine of x. And then I still have sine of x here times cosine of x. Sine of x here is going to cancel with sine of x there. And what I'm left with is just 2 times cosine of x. And there's nothing else I can do there to simplify, so I'm done. Moving on. All right, so again, I've got cotangent. Don't love dealing with cotangent. I'd rather deal with tangent, so I'm going to do some converting with my reciprocal identities. Rewrite this a little bit as 7 tangent of x over cotangent of x. It's just easier for me to kind of visualize it that way. And then I'm going to replace this cotangent of x with 1 over tangent of x, because that's what cotangent is. Now when I'm dividing fractions, that's the same as just multiplying by the reciprocal. So this is going to be 7 tangent of x times tangent of x over 1. I'm multiplying by the reciprocal. I don't really need that over 1. And then I'm just going to multiply those together. Tangent of x times tangent of x is just 7 tangent squared x. Sorry, my pen's a little behind. And my 7 disappeared. There we go. So that is our final answer. We can't simplify any further on that one. Moving on to number 4. Now this isn't going to involve reciprocal identities, but this is a problem we actually did last chapter. This looks pretty similar to our Pythagorean identity. The sine squared x plus cosine squared x equals 1. So what I can do is I can factor out this 13, put that in front, and I'm left with sine squared x plus cosine squared x. And then I can replace this whole thing with 1. 13 times 1 is just 13. Moving on to the next one. Going to do a little bit of reciprocal identity stuff on this one. I don't like cosecant as much as I like 1 over sine of x. And then this is still just sine x. I like cosine. I'll leave cosine as it is. And then I'm going to replace secant with 1 over cosine of x, since those are reciprocals. And then we still have this plus 9 on the end. All right. This part here is going to cancel. This part here is going to cancel. When a fraction cancels out, we're still left with something. We're left with 1. So each of these is just going to be 1 times 1, and then we have plus 9. So really we've got 1 plus 9. So our final answer is going to be 10. This last one, in order to simplify, we're just going to have to use our exponent rules. Remember, if we have something like x, oops, I'll do the same exponents that we have here. X to the 4th over x squared, you subtract the exponents, and you'd end up getting x squared as an answer. It's the same idea with this. This is sine, it's the 4th power of x. We're going to subtract, well, I'll just rewrite this as sine 4 minus 2, so we're subtracting the exponents. This will simplify to sine squared x. Those are all just different ways that we can simplify. Sorry, my screen's freezing a little bit. There we go. Oh, frozen again. All right, finally got it to move. Sorry, my screen's being a little glitchy. So those are all different ways to simplify, and we're going to use those to help us do identity proofs. A lot of you probably cringe when you hear the word proof, but it's going to be a little different than we did in geometry. So an identity is any equation that can be proven true. A trig identity involves at least one of the 6 trig functions. We can prove an identity using several different strategies. So these are going to be great notes to refer back to if you're ever struggling with your identity proofs. And the first strategy is going to be converting everything to sine and cosine. When we're doing an identity proof, the idea is to try and get the left side of the equation and the right side of the equation to be equal to each other. So I'm either going to simplify the left side and get it to be the same as the right side, or I'm going to simplify the right side and get it to be the same as the left side, or some kind of combination of the two of those. On number 1, clearly the left side is less simplified than the right side. So I'm going to try to simplify that left side and get it to be the same as the right side. And I'm going to use this strategy, change everything to sine and cosine. So 7 obviously can't become sine and cosine, but tangent can. Remember, tangent is the same as sine over cosine. All right. And then secant can also be changed to cosine. This is the same as 1 over cosine. It's the reciprocal of cosine. All right, and then cotangent. Well, cotangent is the reciprocal of tangent. So if I'm switching that to sine and cosine, it's the same as cosine over sine. And then now I'm on cosine. That's just going to stay what it was. And then sine just stays what it is. And then the very last thing is cosecant, which is the reciprocal of sine. And then we're trying to get that whole thing to simplify to 7, to simplify to what the right side of the equation was. So now I'm going to have a lot of simplifying to do. This sign on top can cancel with this sign on bottom. This cosine on top can cancel with this cosine on bottom. Here's another cosine on top and cosine on bottom. And then here's a sine on top with a sine on bottom. All of my sines and cosines canceled out. And really all I was left with on the top was 7 times 1 times 1, which is just 7 on top equals the 7 on the other side of the equation. And we're done. Once the left side of the equation equals the right side of the equation, we're done. Strategy number 1, and now we'll move on to strategy number 2, which is factoring and simplifying. So I look at number 2, and it looks like this side of the equation, that left side, is a little less simplified than the other side. So that's the side that I'm going to factor and simplify. Now remember back to algebra, this is a perfect square minus a perfect square. Difference of perfect squares is a squared minus b squared equals a plus b times a minus b. That's the formula I'm going to use to factor this. So this will factor to sine squared x plus cosine squared x times sine squared x minus cosine squared x. So that was my difference of perfect squares formula. And that's just, this is my right side of the equation. I just wanted to rewrite it. All right, and then you might notice I've got this and I've got that. So those parts of the equations are equal, but I somehow want to get rid of this thing. Well, what does that look like? Where have we seen that before? That's our Pythagorean identity, which you might remember, or hopefully you remember, that equals just 1. All right, now the left side of the equation equals the right side of the equation. So we're done. Moving on to the next one. Again, we're going to use factoring and simplifying to simplify this. You might notice there's no equation on this, so this isn't actually a proof. We're just going to practice simplifying this. And when we simplify this, we want to get it so that it's only sines and cosines. I'll write that, sines and cosines, sine x and cosine x. And we want to combine it so it's only one fraction. Once we can do that, it's fully simplified. The method we're using here is factoring. I'm going to factor out a GCF. In this case, the GCF is secant of x. When I divide out secant of x, I'm left with just cosine squared x minus 1. Okay. And then we want to simplify this. Well, where have we seen that before? Cosine squared x minus 1. That's one of our variations of our Pythagorean identity. So, or it's similar to it. It looks very similar to this. So I want it to become 1 minus cosine squared x, not the other way around. And then I can say that it's the same as sine squared x. Oops. I'm all over the place. Sorry, guys. So what I'm going to do is I'm actually going to factor out a -1 also. Just negative secant of x. And then this will become a +1 and a negative cosine squared x. And then this whole thing can just be replaced with sine. Because of the Pythagorean identity. We're almost done. It's fully simplified once it's just sine and cosine, so I'm going to replace this with 1 over cosine. So 1 over a -1 over cosine x times sine x. And then I'll combine that into just one fraction. Negative sine x over cosine x. Oh, I'm realizing I forgot something. This simplified to sine squared x. The Pythagorean identity, that's sine squared x. Oops, sorry about that, guys. So this here is our simplified answer. Now that wasn't quite a proof because we weren't trying to get it to prove the other to be the same as the other side of the equation, but it was good practice for simplifying. The rest of these will all be proofs. So now we're trying to get this left side of the equation to equal this right side of the equation. And the strategy we're going to use right now is splitting up one fraction. So I'm going to split up the fraction on the left side into 1 over sine x plus cosine x over sine x. We can split that up. And we still have cosecant of x plus cotangent of x. And then I can change this to cosecant. Oops, cosecant of x because of the reciprocal identities. And then cosine x over sine x is cotangent of x. So that was quick and easy. We are now done. The left side of the equation equals the right side. So we are done. All right, next one, again, we're using the strategy of splitting up a fraction. So I'm going to split up this fraction, and I'm going to try to get the right side of the equation to equal the left side. We have 2 secant x plus tangent. I'm going to leave that side the same, and I'm going to simplify the other side of the equation. So this is going to be 2 over cosine x plus sine x over cosine x. And then I'm going to simplify those so that they can be the same as the left side of the equation. So I want this to somehow become 2 secant x, which works out because 1 over cosine is secant x, so I can just write this as 2 secant x. Oops. Secant x. And then we want sine x over cosine x to be tangent x, which works because tangent is equal to sine over cosine. So now that the left is equal to the right, we are done. For step 4, I'm actually going to switch this. We're not going to use the strategy that we had typed in here. We are instead going to use the strategy of combining fractions. So don't worry about this for now. We're just going to focus on combining the fractions. This is going to involve a little algebra. Remember how to get common denominators in order to add fractions. So we need these two to have common denominators. This one's going to need a cosine on the denominator. Whatever I do to the bottom, I do to the top. This one's going to need a sine on the denominator. Whatever I do to the denominator, I do to the top. All right. So when I multiply these together on top, this is going to be cosine squared x plus sine squared x on top. And then, oops, my denominator is just going to be sine x times cosine x. Okay. And then remember we need that to equal what's on the right side. Now you might notice that you can do some simplifying with this. Take a look at that fraction, and what do you recognize? Hopefully you recognize that this can simplify. That's the Pythagorean identity, and it just simplifies to 1. So 1 over sine x times cosine x, which I can split that apart. This is 1 over sine x times 1 over cosine x. And again, remember we want that to equal what we have on the right. Well, 1 over sine x is cosecant. 1 over cosine is secant. So the left does equal the right. So we're good. All right, I think that was it for day 1. Yeah, thank you guys.